Yeah, so I mean, I'm going to talk about the more recent history. I'm going to talk about one of the aspects that has been loosely mentioned in some of the other presentations. I'm not actually going to talk about any tools in particular. I came to a part not when it started. I was brought in as a substitute for a tutorial which was at SC. So this was a tutorial which Michael, Bernd, and Bart had organized. And for whatever reason, Bart was unable to go, so I was substituted in to present the Bart's part of the tutorial. And I guess the tutorial must have been about 3 hours, and maybe we had an hour each or something. But in any case, time got dilated, and my part of the presentation got reduced to 5 minutes. And some people said that I went a little bit fast, so if I talk too quickly, let me know and I'll try and slow down a bit. But training was something that APART took seriously, and it's something that I've been involved in certainly for the last years and some time before that. I'm going to talk about 2 parts of it in particular. VI-HPS you've already heard a little bit about from Felix. I'll skip over some of the details there. I'm just going to talk about the training there. But there's also the training that has happened as part of the performance optimization and productivity CoE over a number of years, and so I'll try and work that in as well, and maybe a few other random stuff. So VI-HPS you already know about. One of the key things about VI-HPS was that as well as tools training at tutorials, we, from the start, focused on bring your own code tuning workshops. And why did we do that? Well, this was to address Thomas's concern that you write great documentation about your tool, and the only person who can actually make any sense of it is the person who wrote the documentation. So essentially useless. Or you have a team of people writing a lot of documentation, and then no one reads it, or no one can make any sense of it from that. So trying to use a tool from the documentation is usually unproductive. And that was where the Bring Your Own Code tuning workshops came from. People bring their codes to the workshop, we tell them about the tools, but then we actually sit with them and work with them to use those tools and apply them to their own codes. So these, by definition, are multi-day workshops running 3 to 5 days. We kind of try and squeeze as much as we can into those days and push back. There was a certain amount of pushback if we go beyond 5 days, so 5 days was the maximum that we could try and force people into. 5 days is a really long time for intense training, so 3 days is usually a much better option. We've done tuning workshops now for the last 15 or so years. The distribution of the workshops you can see is mostly around Central Europe. A lot of them are in Germany, but around other parts of Europe as well. But also some have taken place in Asia or in the Americas. And that's more or less because most of the funding for these workshops comes from the PRACE, what was PRACE in the past, and we're still trying to work out how to fund things going forward. So as I said, these workshops center around people bringing their own codes. They come together, usually, ideally they would come in pairs or 2 or 3 people working on the same code that they're familiar with, and code that they care about its performance and how to understand its performance and improve its performance. Often it's the case that the people who are responsible for the code and its performance aren't the ones who actually wrote it. The code was written 100 years ago by some grad students. No one remembers how that code works, but someone has to maintain it and, quotes, optimize its performance going forward. And so they need tools that help them understand execution performance, as well as what are the options that might be involved in improving performance on the current systems and on other systems. These workshops were always in person initially. During the pandemic, we had to transition to virtual events. That worked remarkably well within the limits of virtual events. And we're still working out to what extent we will continue virtual, hybrid, and in-person events going forward. There's a role and a need for all 3, as we've seen. So where did we start? We started 2008. The first workshop was organized by Dieter and Mai at the RVTH in Aachen. And he came up with this format of doing short presentations and demonstrations of the tools, followed by a chance for application developers, the analysts, the people to actually try out the tools, get a feel for them, compare how they performed, how they worked with their application code. So not only with toy problems, with small benchmarks, but with their real application codes. And this is where the real challenges start. Does it always work? No, there's often problems. Sometimes it works, sometimes it doesn't. But it's a learning opportunity not only for the attendees, the participants, the application developers, but we also get direct feedback to the tools developers about what works in the tools, what doesn't work in the tools, what are the snags that they run into where we could improve things and make things easier to use in future. So that's been a very productive feedback cycle, not only for the tools developers, but I think for the wider community. The workshops haven't been exclusively focused on the VI-HPS tools, which are all great and cover a lot of cases, but we have external guest tools as well. So usually if we're using a Cray system, Cray tools get included. If it's an IBM or Intel system, their tools get a chance to be compared with the VI-HPS tools. Comparing the in-depth information you can get from vendor tools with the more portable information you get across systems from tools like scalability, Scalaska, which you've heard about, allows you to get a feel for both aspects there. How you get very detailed information from the proprietary tools, but also how you get portable information across multiple systems from the portable tools. So after the initial workshop, we did another couple of workshops in Germany. We did a few more over the years. You can't really follow the numbers there. I have another slide somewhere else with dates for all of them, but we did, for the first few years, we did 2 or 3 workshops. Then we had more demand. We tried to fit in a few more events. We've kind of consolidated on 3-4 events in the VI-HPS format per year, as well as other training, which I'll mention and when we come to that. I took on the role as the training coordinator for the first years of VI-HPS. That became increasingly a conflict as the POP Center of Excellence got up and running, where we were also doing similar workshops, sometimes in conjunction with VI-HPS, sometimes not. So I was happy to hand over the VI-HPS side of things to Cedric Valenci from Versailles. Unfortunately, he took things over just as the pandemic was starting. So the first events got immediately cancelled or postponed, and then we had to figure out, can we do these events in any shape or form in a virtual format? And as I said, our initial reaction was there's no way it can't be done, but we did it, and it worked remarkably well. But after doing a few events, it was clear that we're lacking interaction, not only between the participants and the instructors, but also between the participants themselves. They don't have the same opportunities to share the knowledge that they have. Even if we put people together in a breakout room, if they're doing everything through a screen, you have much less engagement and interaction between them. They're much more reticent about sharing information. So the in-person events are really important, and it's great that we have managed to get those up and going again. There was one in Toulouse a couple of weeks ago. We have 3 more scheduled in the calendar for the first half of this year. Getting into some more detail about the events themselves, we always started, or we were motivated to start with demonstrating the tools with an example code. Not a code that the participants are expected to understand or be familiar with, but just something that we could quickly get running on the system that would be used, and that participants would then be able to see how the different tools that were presented worked with that application. We initially started with trivial codes like Jacobi solvers or matrix vector multiplies. Those are way too trivial for actually to be any use for any meaningful purposes. We went through a few other benchmark codes. Eventually, we ended up with the BT solver, the block triangular solver from the NAS parallel benchmarks. initially an MPI version, which was de rigueur at the time. In some cases, we went and used an OpenMP version. When the hybrid, the multi-zone version of BT came out, it was MPI plus OpenMP. This was great. We could use that for both communities. The people who only understood MPI could use it. The people who only understood OpenMP could use it. And the very few people who were in any way unable to understand hybrid codes, they could also get something from this benchmark code as well. And what the tools presented about its execution and its performance. That took us up to the era where GPUs became widely available, widely prevalent. Initially, those GPUs were programmed with CUDA, proprietary coding interface from NVIDIA. So we did some workshops with that. Now we're trying to get beyond that point to get to something a bit more portable. Currently, that's brought us to OpenACC. In the future, we hope it'll bring us to OpenMP, and we'll be able to support OpenMP not only on the CPU side, but also on the GPUs as well. We're not there yet, but that's where we think we'll be in a year or so's time. A downside of using highly portable benchmark codes, which run everywhere, is that they tend not to demonstrate significant performance inefficiencies, which, if you're demonstrating performance tools and talking about performance problems, it would be actually quite nice to be able to show those problems as discovered and presented in the tools. Of course, you can put in delays and other factors that affect the performance, but those are always nasty hacks that were never satisfying. Another way, of course, to kill performance is to throw in some I/O. That's easy as well, but again, it's not really the I/O that application developers are interested in. But I mean, that was a starting point. We had codes that were highly portable, but also highly scalable. They could run on a laptop computer in a virtual machine, or they could run on a Blue Gene system or Fugaku or K-computer, whatever, with tens of thousands of processes and threads. And the nice thing about those benchmark codes, because they were used for procurements, is that they had a distinct kernel where the performance was important, and they also validated that the execution was valid to whatever tolerance was expected. It's never guaranteed that when you apply a tool, when you change things, that the performance, that the correctness is guaranteed. So if the application itself can say, I'm still running correctly, that's a good confidence factor to have. And it's a good point to encourage in the application developers as well. So that's part of the evolution of the example codes. We learned that what makes a good example code and what makes a good test code for the real applications is something that's not too long but not too short. If it runs in a few seconds, no one cares about its performance. If it runs for a few days, the performance is important, but we can't do enough iterations of the analysis in a typical workshop. So to be able to run the code and run the application several times and apply different tools to it, we're really looking at something in the 1 to 2 minutes range, maybe 5 minutes. If it's running much longer than that, it's taking really too long to give enough cycles of change and applying different tools. Whether you're changing the code, whether you're changing the instrumentation, changing the measurement configurations, all of those require you to rerun the code, and if it takes an hour to run, then you just don't get enough cycles through that. Related, of course, is what sort of resources are you using? If you need to run on the entire Blue Gene system, well, that's great if you have it, but most people don't. Likewise, if it just runs on a single, with a few processes on a single node, you're not going to learn much about its large-scale performance issues and scalability. So you need something in between, depending on whether you're using a notebook computer for your workshop or whether you're using a HPC partition of a real large supercomputer. Typically, we would look for something that is beyond a notebook computer, because there you're really constrained in what you can run. They only have a few physical cores, and if you go into virtual cores, you have all sorts of other performance artifacts coming up that typically don't apply on real computer systems or HPC computer systems. A single node can be fine if you have had dedicated access to it. compute nodes these days are pretty complex in themselves. They have multiple processor sockets. They might have hundreds of cores. They'll have multiple numerair all of which affect performance. So you can do a lot of really important performance analysis at the single node level, but as soon as you throw a few nodes together, you have all sorts of other interesting and important aspects from internode and not only intranode communication, but also internode between nodes, communication and performance. And if you're planning and hoping to scale to large-scale systems, then of course that's critical. Typically, we don't require for our workshops access to very large numbers of compute nodes, but it's great if you do have access to those, because then you can run much larger jobs. You can run on 10, 100, 1,000 nodes and look at your scaling analyses using the same tools as part of that. But you don't need to do that during the workshop. That can be done in one of the breaks or overnight when the resources are available. With the example codes we were using, whether it's BTMZ or the subsequent codes, it was valuable for us to provide job scripts, which people need to use anyway on the HPC systems. They can use them for reference, they can see how the tool has been incorporated, and then they can easily adapt those to their own application. So that was very valuable to have a collection of those as we built it up from the early days through Blue Gene systems, through K-Computer, etc. Taking the basic makefiles that the BTMZ or other applications use and putting annotations into those makes things easier to use, because as soon as you tell people to go into a makefile and change things around, many people are a bit lost and can't really follow that. So if it's just a matter of go to this line and uncomment it, that's kind of doable. Often it's preferable not to actually mess around with the makefile at all and to do all of the instrumentation reconfiguration from the shell, from the command line. There are ways of doing that through a preposition for adding the instrumenter before the compiler or linker. So those make things a bit easier to use as well. And once you've gone to the step of putting the annotations into the makefile, which are there for reference, you can also put additional annotations into the source code as well. So you can mark the parts of the code that relate to the solver or the iteration loop that is particularly interesting. You can put in additional control functions to disable measurement for the initialization or other parts that are not so critical. And again, those are not things that the application developers need to mess around with and change, but they can refer to them and take that knowledge and apply it to their own codes. And we usually put together a few other files that go along with the instrumentation and measurement that the tools are using, so filter files and other things that can help you to make much progress with the measurements that you're doing. As I already said, if it's a single source file example, that's really too trivial to be useful. You need something with a makefile with multiple sources, ideally in multiple directories, but you don't want something that takes hours to build. If it takes an hour to rebuild the code, that's also not productive if you need to make any changes to it. So something that's a few files, or at least something that's capable of being rebuilt in a few minutes, and it needs to be a factor that's taken into account. We have primarily used Fortran examples. Fortran examples are really great for discovering things that the tool developers never look at. And that's usually very valuable because it's still the case that between a third and a half of the codes that come to the workshop are always Fortran codes. On the other hand, the tools developers do a lot of testing of C and C++ because those are the languages that they're more familiar with. C++ examples are always really nasty and horrible to work with. They are much more complexity, they're completely non-portable. So usually that's a challenge. It's not one that I necessarily want to shy away from, but Fortran's a good compromise between something that's too trivial and something that's too complex. And the participants never need to modify the code anyway, so they don't really need to care what the language is that it's using. As I mentioned, we needed to go over the years from starting off just looking at MPI, which had a really great interface that every tool could use, and you could really compare what the different tools were doing there, to use threading in various ways, usually OpenMP, sometimes in other threading models, And then over the last few years, the big trend is towards offloading parts of the code, kernels to GPUs and other accelerators. So having a single code that combines all of these really is a complicated business. There are codes that do it, but it becomes much more complexity to deal with. You still have the complexity of turning off one aspect or the other and just looking at the others, but that's really still a big challenge. It also becomes rather more challenging to figure out how do you adapt things in terms of the number of processes, the number of threads, what sort of offload is going on to still have the runtime be a manageable 2 to 3 minutes as well as the compile time. But in any case, having everything available in a single code does open up the opportunity to try out different things and to compare what happens if you increase the number of threads or decrease the number of processes, do more or less offloading. All of those factors can be part of the experimentation process, which is part of familiarizing with what you can learn from the different tools that are available. Despite that complexity, the people coming to the workshops really don't need to care about it. They don't have to modify the source language, so they don't really need to care if it's Fortran or if it's C or C++. They're not going to be modifying the code. They don't need to understand its performance, but they do need to understand their own code and the languages it's using. While MPI and to a certain extent OpenMP are pretty standard and used widely, there's all sorts of other variants that come up now and then, or to varying degrees. So some people prefer to do their own p-threads rather than use OpenMP. Increasingly, people use the standard language features from C++ and Fortran to use the concurrency features there. There, the tool support is very minimal. So we can capture all the things at the p-threads level, but that's completely distinct from what they have written in their code at the C++ concurrency, whatever, or Fortran concurrency. Same thing is at the accelerator level. If you are using OpenMP or OpenACC to offload things, then you typically don't really want or need to see what's happening at the CUDA level or the HIP level of the GPU itself. You can get that information, but how you relate what part of that CUDA and GPU activity comes from your code and the libraries that you're using versus what part is coming from OpenACC or OpenMPP is a bit of a challenge. So there, typically the best thing is to disable the CUDA part or the GPU specific part and just look at the CPU perspective from OpenMP and OpenACC. We're still working through these issues, but that's kind of where we are at the moment. Virtual events are something that came onto the agenda in the last few years. Participation varies widely, depending on how reliable your network connection is, how slow it is. That's a big factor for a lot of participants. Trying to do everything at home from a laptop screen is really a nightmare. You need 2 or 3 screens where you can have one screen dedicated to your terminal session, one where you're following the presentation, another one for your Slack or your communication channels. And not everyone has 2 or 3 laptops or 2 or 3 monitors set up at home or in their office for that purpose. So that's a limitation. Some people are able to juggle 2 or 3 windows in their browser or on their screen and make them all really nice and small so that they can read them. Sometimes it works for some people more than others, but it's really a technological barrier to a lot of people being able to participate in these sorts of workshops. And of course, the other big thing is that if you're in Australia or if you're in Brazil and you're attending a workshop that is in European time, it's really unfriendly hours, and that really reduces the productivity of people when it gets to 2 or 3 a.m. in the morning. Their attentiveness diminishes. Usually they drop out and don't continue at that point. But we have had a lot of uptake in our workshops with people joining from Asia, from Japan, from Australia, India, all of that side of the world, as well as from Latin America and the US as well. So to a certain extent, people are able to be flexible and to join a workshop, but it's fairly brutal, and it's certainly not the most productive format. It is, of course, attractive if you don't have a travel budget, both for the potential workshop attendees and also for the instructors, because doing things from your office or from home avoids that. It also kind of fits into people's schedule better, that they don't need to fit in time for travel, so they can just turn up in the morning and say, I'm going to attend the workshop today, or maybe I'm not. And if they are attending the workshop, usually they are not very attentive. Often it's the case that the session is going on, but if there's any questions asked, there's usually not much in terms of, or there's a few people who will be active and will be interacting, but the majority of the participants, you have no idea what they're doing. They're at some other icon on the screen which is showing that they're connected, but you have no idea what they're doing. And in most cases, they're doing something else, not actually actively following. So virtual events are fundamentally a poor alternative. That doesn't mean that they're useless. We still think there's a role for them because of their upsides, but they're certainly no replacement for real in-person workshops. From a real person workshop, an in-person workshop, you have a direct interaction with the instructors. You also have an interaction with the other workshop participants, and so that's a great way of learning from the participants, of them helping each other. For the instructors, it's easier for us to just wander around the room and see what's on people's screens. If they're reading email or messing around with some other stuff, we don't need to spend any time with them. The ones who are struggling with the use of the tools, we can dedicate our time to assist them. And when you're together in a break session, whether it's over coffee or in the queue for the restrooms, there's a chance for some feedback that you don't get in a virtual event, where as soon as there's a break in proceedings, everyone's away from the screen, everything is dead until the next session starts. I already mentioned interaction is a really important part of it, and also the fact that there's fewer distractions. If you're in a classroom like this, if there's no distractions such as great weather and skiing outside, you're much more likely to actually do some real work and benefit from the time that you spend in that workshop. If you're at home, there's all sorts of distractions there. If you're in your office, there's things going on. You'll skip out for a meeting or things that just don't happen to the same extent if you have traveled 24 hours to get to some obscure location and stay there. Accumulated knowledge from workshops. During the pandemic, we started recording things, and actually there were some workshops that were recorded before that, but during the pandemic, the recordings became pretty valuable because of people's problems with network connections and whatever, they could really go back to the recordings and catch up with the parts that they missed, and they could also go through things at their own pace. And half of the people will go through things 2 or 3 times to go through the tough bits and make sure they catch it. Other people will just put it on 10 times replay, and for them that's enough, 10 times playback speed. And of course you can do that not just the day after the event or whenever the recordings go online, but the next week, the next month, or sometime later. Also people who have attended some of the other trainings, earlier trainings, they don't need all of the step-by-step part, but they can actually benefit from just casually scanning the recordings and then looking at the parts which are new to them and focus on them. So recordings are really great, and we should try and do more of them, even though there's a cost associated with setting up the equipment and putting the recordings available in a convenient fashion where you're not continually disturbed by videos from other things. I think the state of play at the moment is that everyone realizes that hybrid virtual presence training is the worst of both options for everyone involved. You are duplicating the resources for the physical classroom plus the streaming resources. It's twice as much work for the hosts to manage both communities. It's twice as much work for the instructors to manage both, and they have to do it concurrently because they're both happening at the same time. So this is a big challenge that, of course, you can throw more instructors at, you can throw more resources at, but even when you do that, you still have the fundamental challenge that the schedule is awkward and inconvenient for both, because if you have to take time out of the in-person workshop to help the online participants, that's disturbing for the in-person folks who have made the effort to be there, and likewise the interaction and the pace for the in-person participants is usually different from those who are working remotely and may not have the same network connection to the HPC resources that we're actively working with. So both communities, both types of participants lose out in those combined events. It's a little bit of a transition. It's a bit of random back and forth between different things here, but the main people who lost out during the pandemic were the same people who always lose out. I look around this room, I don't see any women. Why is that? I look around our normal training events, we typically have 20 to 30% of the participants are women, sometimes more, sometimes much less. Some workshops are entirely male. The mixed events are, of course, always much better, but if the women don't apply, then we're doing something wrong. We have really great instructors. I don't want to read out the entire list, but the names are on the slide here. People who have done many of our training events and continue to do so, others who are just getting started. But I think within VI-HPS and within the community as a whole, there's many more women who are keen to get involved, and we should bring them in. So that's kind of what we've been trying to do, or which Judith and I have been trying to do. A couple of years ago, we brought up this issue at the VI-HPS level. We were asked, what are we going to do about it? And of course, we got challenged to become co-chairs and do something. What have we achieved in terms of diversity, equality, inclusiveness, accessibility, justice, all of these nice factors? Well, one of the things that we have experimented with, and I'll come to in a moment, is workshops which are specifically buy-in for underrepresented groups. And of course, the biggest underrepresented group are women and people who identify as female. So that's been a focus, trying to get more women instructors in our pool of instructors for our training events and giving them increased visibility when they are training at our tutorials, at our workshops. Another underrepresented group, at least from the European perspective, are the countries of the East, former Eastern Europe, European countries. They came late to the game, late to the European integration activity, and so that's why a lot of our workshops, in fact, none of our workshops have taken place in any of those countries. Austria is mentioned here as well. Austria could be a good target for a future training and workshop. So a couple of years ago, we started with experimenting with workshops organized by and primarily for women. I'll come to those in a moment. Last year, we were unable to do any of those for a number of different reasons. We're going to try this year, if we can, to do one looking pretty dodgy. I don't think it's going to happen, but it's definitely on our agenda to address this community through some pretty radical workshops. That doesn't mean that we don't want to have women involved in the other workshops, the academic workshops like Pro Tools. Some years they're well represented. Last year, none of the chairs were women. I'm pushing hard this year to get at least half of the chairs, the co-chairs, to be women this year. I'm struggling. That was the VI-HPS side of things, and I'm just going to switch now to my POP presentation, which will be a bit shorter, and I think complements what is happening at the VI-HPS level. So POP, the Centre of Excellence for Product Performance Optimization and Productivity. The COE just got started again last month, beginning of January, so we're still ramping up our services again, but this is a third instance of it, so we kind of know what we're doing, but we also know that the challenges of the new systems like Jupyter, which is on our horizon, are substantial, and we need to do work there. There's a lot of different players in training that we have to interact with. VI-HPS, of course, being one of the main ones. Price was a big factor in the past. Price, we're still trying to work out what they're doing because there's a whole lot of new non-Price initiatives that are at the moment more important because they're funded by the EuroHPC organization. So I don't want to read out all the names. If you've heard of them, great. If you don't, it doesn't matter. Those are all in Europe, of course. Europe is still our base, where our funding comes from, for the largest part at least. But activities with the US through the Access program, formerly it was Exceed. With the UK, their big program is Excalibur. With other countries like Switzerland, regional activities in ASEAN and with Latin America, as well as specific project partnerships that we have with other organizations. So there's a wide community that we have to interact with. We have to train performance analysts in the new COE, which we're starting. There'll be new people hired to do performance analysis. They need training in our tools and methodology. We are planning to continue to do VI-HPS tuning workshops. We'll continue to do tutorials at conferences, as well as contributions to other schools and training events which have taken place around the world. I don't have time to go through all of them. I'm just going to focus on the training by and for women, where in the POP proposal, we said we would do at least one event per year. So we had that in our schedule for POP 2, or at least we said we'd try it a couple of times and we did 2. We want to continue with that. On the VI-HPS website, you'll find out about the upcoming training workshops. We did one last month in France using ARM plus NVIDIA GPUs. So that's a nice starting point for people who are getting ready for Jupyter. Some of the next workshops coming up are in Aachen and Dresden. There's also one scheduled for beginning of June at LRZ and Munich. So that would be another opportunity for people who are interested in learning about the tools. We're hoping to do our first event in the Eastern countries in Ostrava. We're hoping to do that in September, and we already have a pretty full program for this year, but there's more can be done in subsequent years. There's various other training activities that go along and complement the VI-HPS tuning workshops. Some events are focused on specific tools, like the performance tools at Barcelona using Mare Nostrum. I didn't prepare any slides for it here. It's kind of interesting, our performance analysis workshop series that's been done with the Excalibur folks in the UK. Instead of doing everything crammed into 1 week, we do 1 day a week over a month or 2 months or even longer. That worked out really well during the pandemic, where travel was a problem for instructors as well as for participants. But that's also a good format for people to have a break between when they learn one tool, to have a chance to try it out and really go into some depth with it before you go into introducing another tool 1 week or a couple of weeks later. We have some training specifically for the AMD GPUs in the UK, and we're still waiting to hear whether our ISC tutorials are accepted for this year. Training is planned on the Fugaku system in Japan in the summer in conjunction with the International HPC Summer School, and there'll be various other trainings that we'll be expected to do in the course of the year as well, using Leonardo, for example, this year, the big system at Jülich. Workshops buy-in for women is something that I resisted for quite a while. I thought it was a bad idea in many ways. But when you look at the statistics of doing 40-odd workshops since 2008, attracting 650 participants, where the majority of are male, our instructor team, again, is predominantly male, with one or two prodigious instructresses as exceptions. But the women of the POP CoE in the last instance and continuing in the new instance have been inspired to address this issue and to improve the participation of women in our workshops. Primarily getting women to come to the workshop and to learn about the tools, but also by putting together a team of 8 instructresses and assistants who deliver those workshops for the participants. It says it's for women. It's not exclusively for women. We do allow men to take part in those workshops where capacity allows, but we're sensitive to the balance there, that if it gets to 50-50, the dynamic changes. Really, if it gets above 25% men, the dynamic is noticeably different. So we're still working through the details, and of course these were virtual events where everyone is just an icon on the screen or a voice at the end of the breakout room. We're still hoping we can do an in-person event and see what happens when a team of instructresses and a team of participants get together in the same room and can really interact. The women who came to these workshops were really enthusiastic and really curious about such an event because few had any experience of such training in the past. It's a bit unusual. But it was nice to see that the participants were less inhibited about asking questions and seeking assistance compared to male colleagues at mixed events. And they were also more open in sharing about collaborating, not only with the instructors, but also with the other participants, helping each other out and sharing what's working for them or where they're struggling and need some assistance. So that's very positive. It was only 2 events. That's not a good basis for any statistical analysis. I was able to listen in as sit at the back of the room for one of the events, and also the feedback from some of the other experienced instructresses was that they perceived relatively little difference from the mixed events. So the quality of the participants was the same, what they got out of the events was the same, the feedback in terms of whether they liked it was more or less the same. But at the same time, the atmosphere was claimed to be better and more conducive to interaction, and that's not a bad thing. We still have to figure out what impact this has on our general workshop participation rates. Does the number of women who come to our mixed events decrease? So far, that hasn't happened. It stayed at roughly the same level, as I said, between 0 and 30%, which covers a lot. But we think there's also a real danger of establishing segregated training as a norm, which is really against the whole concept of diversity and the fact that diverse communities coming together for these events are a really positive environment for sharing and for learning. One of the things that we weren't really expecting, but was a really pleasing outcome from the events, was that the teaching confidence of the less experienced instructresses was really boosted immensely. They were much more involved. They were getting a lot out of things. They were able to have recognition of the fact that they are able to present these tools and help people with the use of the tools. And they have been also motivated to join the mixed instructor teams that we use for our general workshops, as well as at the high-profile tutorials at international conferences. So that was a nice thing to see, and it's definitely something that we want to pursue in the future. I'm not going to say much about skills and certification. It's obviously the more and more of a trend for people to look for badges and certificates that they can put on their CV or on their online profiles to say that they're qualified analysts or qualified in the use of one or other tools. But we also would like to take this further and be able to certify our instructors. Not only the junior instructors who are first starting off, but also the more senior ones who can lead training with our tools and methodology for others. And there's all sorts of activities going on in Europe that we want to leverage for that. That's the end of my presentation. I think I didn't run over too much, but I'm certainly open to your questions and your feedback and your experience from other training, whether it was good or bad, that you'd like to share.
So Brian, I really laud you guys' inclusivity, diversity efforts. You are finding a pipeline of education in the more engineering side, computing, that is somewhat more sparsely populated. So, I mean, you are doing well, and it'd be great to expand it. But, you know, when you see these events, we get 30% attendance. What would I say? That may be.
That may be a good target, and maybe a realistic target.
I look at my classrooms, and like we teach I teach operating systems and software security, and I see 25 to 30% as steady state, and I work on that, but it's hard. It's a hard problem.
We are at the advanced user level, so there's a whole pipeline of girls and women coming up through the schools, through the universities, before they start working with Fortran codes on Jupyter or HPC systems. And we're working at those as well.
Where if we, we're reaching down into our regional high schools, trying to get girls at that, young women at that level more involved, and trying to reach into economically challenged areas. We're trying to get kids from those areas involved, things like that. So it's hard at our level, but anytime we can reach down below the university level as a community, we can improve the pipeline at the university level. Yet one more thing to take on.
And I recognize that, and we are with our limited resources, but we also recognize that our expertise is at the advanced level, and there's a demand there that we can't really suitably address, and we need to expand. And so that's not the easy target, but it's the initial target that we can address and build on and expand from there.
Keep doing good stuff.
So great effort, Brian. I didn't know much about this. I'm really impressed. But I was wondering, I am Michael, yeah. I was wondering, it looks like you probably can just mention how you collect information from the attendees, because you probably run questionnaires or something. Do you collect information about the type of codes or benchmark that they want to actually see being covered in the training?
Yes, I mean, when people register, they tell us what sort of code they have, what language it uses, what parallelization it uses, what tools they've used in the past with it, so we know what we're starting from. And to a certain extent, we can't address all of them, but we can try and come up with a happy medium that suits the wider.
Yeah, in the next versions of the workshop, so do you see some kind of changes in the type of benchmark codes that
Oh, yes.
the community is interested in?
Yes, we see much more Python, we see much more Julia, we see much more AI stuff, which, to be honest, our tools don't do a good job with, and we try and discourage those people from coming to the workshops because we can't really help them. But there's certainly performance issues in those communities, and the fact that our tools can't really help them, there are other tools that might be, but that's not my expertise at this point.
So I first have to say that this is an enormous effort to do all these tuning workshops and make the tools run on all the platforms, and I know what it means because I participate in it.
And you've hosted some of these workshops as well, yes.
No, but that is really impressive that it goes on for so many years and always new systems there, new applications and so on. I think it's enormous, yeah. So that's one thing that I want to say. The second one is, you mentioned that you have these recordings from the pandemic time, but these are not offered as sort of tutorials that are, let's say, on YouTube or so you offer tutorials for people to look at and learn about them.
There are recordings from some of the workshops that are accessible from the VI-HPS website. There are some of them which are in the YouTube channel. There are some of them which are on other random channels. There are some of them on the POP website which were specifically targeted to training. It's a bit of a mess. They're all over the place. And of course, some of them are now pretty old and dated and they would need to be revised and updated. That's a whole different dimension of extra work as well, to have recordings that are topical and kept up to date for each of the different tools on the different systems.
Do you have any idea about statistics, how many people that were not on your workshop, but find your whatever, online tutorials, actually take them, or?
I don't have statistics. I don't keep track of the numbers, but we're always contacted by people who come into us and say, I learned about your tool through this tutorial, and can you help us, or when's the next workshop that we could come to in person from it? That's just one or cases that come up on not a daily basis, once a month typically.
YouTube and Vimeo will give you statistics on that. But we do that. We have our software security curriculum online with videos, closed captions, the whole thing, and we have that challenge of high performance computing and software security share the idea that as soon as you write something down, it's obsolete. So as soon as you record it, it's a month obsolete. And it takes that much time to edit and things like that. But it's a great effort to put this out, but it's a whole extra increment. I mean, if you can break things up into modules, these 5 to 15-minute modules, and teach components of it, and record that,
Yeah, I mean, the 5, 10, 15-minute videos are certainly accessed much more than the ones that go for 90 minutes or longer.
Okay.
That's clear.
I mean, you want that 90 minutes of material, but you want it in units, and people can then do random access to that, because you cover a lot of stuff in 90 minutes. In my code, it may be only relevant to a third of that 90-minute presentation, and so I can pick and choose. We do the same thing at the security level. That we break things up into small things, and then different people link to that and mix and match.
Oh yeah.
When we teach our course, we go through the whole thing, but when we're other people using it with professional training and mix and match.
People take our stuff and they translate it into Japanese and Chinese, and I have no idea what they're doing, but I see our examples and them talking about it and reaching a community that we can't reach directly.
So you mentioned that people bring in code bases which are Python for specific ML workloads. So are there any tools which can actually find bottlenecks in those kinds of applications, or can you actually analyze the intensity of PyTorch with any or find? So how do you?
We can analyze those codes with our tools, and they'll tell you what's happening at the pthreads level, if that's what you want to know. But you don't. No one wants to know what's happening at the pthreads level. Because you're writing something at a much higher level, or PyTorch is working at a much higher level, and we don't have that mapping information. So we just see, okay, you've run this code, it's using several thousand threads, not continuously, but at various points in time. Are they being used productively? Probably not, but we can't really tell. I would hope that within the community, I understand that within PyTorch there is a profiling interface. There are interfaces. I've never used it. Is it any good? I can't say. But people bring their codes to our workshops. So my guess is that the standard interfaces aren't very good, and people are looking for something extra, and they're desperate, and we can't really help them either.
Maybe an add-on to that question, Lisa. What are they looking for? Since they may be bringing to your workshops and things like that, but are they looking, what level are they? Clearly not the p-threads, because that's what you just said.
They don't care about the p-threads, and they don't care about what's happening inside PyTorch, because they're not going to rewrite PyTorch. What they want to know are what are the PyTorch parameters that they can adjust to improve performance. I have no idea what those parameters are, but there's probably several thousand of them that you could play around with, and a tool that addressed that would be the tool to use.
Okay, so I think we should stop. Yeah, otherwise we have no.
Thank you.
Thank you.